Hello, I'm teacher Ivan, a teacher of mathematics and physics at Angel High School, who works with the WUNNA Educational Services to ensure that every learner is given opportunity to high quality education. We are still looking at mechanical properties of matter, and we are concentrating on the states of matter. Yes, in our previous video, we saw the learning outcomes of this chapter, the competence of the topic. So we are continuing where we are going to discuss more about the states of matter. We define the matter as anything that occupies space and has weight. We looked at a number of things. You yourself, you are matter because you occupy space and have weight. The materials that we use in our daily life, the water we drink, the food we take in, the materials we use, books we write in, the computers, name them, there are many. However, these many examples of matter are categorized into four major states. There are very many states, but others are rare. However, we have four major states. That is, we have the solids, we have liquids, gases, and lastly, plasma. We have been looking at three, but because of the advancements in technology, plasma is becoming a very common state. For instance, those who have flat screens, they are called plasma TVs. So it is becoming one of the commonest states of matter. That's why we need to look at what it is, its properties, and where do we find it. Otherwise, among these many examples of matter, we group them into four. So we shall have those that are in solid form or solid state, we shall have those in a liquid state, we shall have those in a gaseous state, and the plasma state. For instance, water is in a liquid state. The beverages we enjoy are in a liquid state. But the pen, the book, the desk, and even yourself, you are in a solid state. And then we have the oxygen we breathe in. That is in gaseous form. The smoke that is given out when cooking is in gaseous state, among others. For plasma state, we shall look at it in particular. However, plasma state is a state of gas at very high temperatures. When the gas is heated at high temperatures, the molecules that make up the gas get charged, and therefore they get ionized, and that ionized state of gas is what we call plasma. So let us look at the properties of each state of matter. We shall start with the solids. However, these properties are shared among the states of matter. Only that these states of matter have different behaviors, as we shall see when we talk about the arrangement of particles in these states. They all have particles, but are arranged in different ways. And the arrangement of the particles give us the properties and behaviors of these states of matter. So as we are looking at the properties of matter, we have outlined 6 major properties of matter. and these states of matter behave differently within these major properties. For instance, when we talk about the arrangement of particles, for solids, particles are closely packed together, whereby they don't have space for movement, and they instead vibrate within their mean positions. So that is for solids. For liquids, the particles are loosely closed together. They have some free space of motion, not like the solids. So for liquids, they are not so tightly closed as compared to solids. However, they are having limited space or limited allowance to motion. Then when we come to gases, gases are made up of loosely bound particles, or the molecules that make up gases are spaced, they are free to move. That's why a gas can easily fill up a container, because its molecules are always in motion or have less bond. That is arrangement. Then when we talk about the intermolecular forces, the intermolecular forces, these are forces of attraction or repulsion between molecules of a substance. Those forces depend on the arrangement. For instance, in the solids where particles are tightly close together, they have stronger forces of attraction. Whereas in liquids are strong but not as those in solids, because in liquids we've seen that the particles are not tightly packed together. They have some room for movement, little room for movement. Therefore, their forces of attraction, or the intermolecular forces between the liquid molecules, are not as strong as those of the solids. When we come to gases, gases have the least forces of attraction between the molecules. The intermolecular forces in gases are weak. That's why molecules in gases move freely, because of the weak intermolecular forces between the particles of the gas. And for plasma, it shares the properties with gas, because actually in most cases we even say that plasma is a subset of gases, because plasma is a state of ionized gas, meaning plasma is in the form of gas but ionized. So that means that it sometimes share the same properties as the gases. Then when we come to the motion of the particles, still it depends on these two. Where we have tightly packed molecules, they will have very strong forces of attraction, and therefore they will not be free to move, but they instead vibrate within their positions. So solids have tightly packed particles, and because of that they have a strong force of attraction between the particles, whereby motion is limited. They don't move, but they just vibrate within their positions. Whereas for liquids, they have some little room for movement, and therefore the molecules or the particles in liquids move, but within a limited area. Whereas for gases, since they have weak intermolecular forces, Therefore, they are free to move randomly in any direction. So that is for solids, liquids, and gases. And we are looking at the motion of the particles. When we look at the shape of the states of matter, still the shape depends on the arrangement and intermolecular forces. For instance, in solids, where we have tightly closed particles with strong intermolecular forces, that means that the solids will have a definite shape because their molecules are bound together to form a solid block with a shape. Whereas for liquids, they are loosely packed and therefore they have room for movement, and that means they will have no shape. And therefore, liquids take the shape of the container. The same applies to gases. Gases are widely spread and they are free to move in any direction. Therefore, they don't have definite shape. When we come to the rate of diffusion, the rate of diffusion depends on how much free can the particles move. And therefore, it will be highest in gases because gaseous particles have a lot of freedom for movement. Therefore, the rate of diffusion is highest in gases, whereas it is high in liquids and very low in solids because of the tight bond between the particles of the solids. That makes the diffusion less in solids. Then when we look at the compressibility, that is the ability to be compressed or the ability to change the size when an external force is applied. For solids, solids are tightly packed and therefore they have no room for compressibility. Their molecules cannot be compressed since they don't have any free space within. The same applies to most of the liquids. Some are slightly compressed, but most of them cannot be compressed. Then we look at the gases. Gases can be compressed because they have the least intermolecular forces of attraction between the molecules. So those ones can be compressed. And because gases can be compressed, that's why they are used to inflate the car tires, the balloons, the footballs, and so on. We use gases to fill the car tires, the balls, the balloons, because they can be compressed. And we use the lightest gas. So those are the properties of the states of matter. Otherwise, in our next video, we shall be looking at the change of state of matter, what causes the change of state, and how does it occur. Otherwise, I'm teacher Ivan from WUNNA Educational Services. I hope to see you when you subscribe, like our pages, and join our groups. Thank you.